Well, welcome to this online revision session for AQA FP4, in which we'll be looking at 2011 question 7 on determinants. As you can see, we're given the 3x3 matrix, determinant delta, and there are a series of parts where we have to relate various factors of this determinant in a number of different ways. Well, in the first part, we've got to show that n squared plus n plus 1 is a factor of delta. Well, in order to do that, we need to look at some row or column operations from which we can find n squared plus n plus 1. And we can see here we've got n squared plus n. So if we add 1 from this column, that will give us n squared plus n plus 1. Then we can see that the n plus 1 and the minus n plus 1 are opposite sign, and likewise the 1 and the minus 1 is an opposite sign. So if we take row 1 and add row 3, we know with row operations do not change the value of the determinant, and so the determinant will then be equal to n squared plus n plus 1, 0, 0, second row will not change, and the third row will not change. And so now we can take out the n squared n plus 1 as a factor, and the matrix we're left with in the side here is just 1, 0, 0, 0, 1, n, and 1, negative n plus 1, 1. So that's shown the first part. Now part 2 now asks us to find the factorised form of this determinant. Okay, and from what we've now got, it's relatively easy to expand using this top row to find the remainder of this determinant, and so the determinant will now be equal to n squared plus n plus 1, and the only part we've got here is going to be multiplied by 1 times the 2 by 2 determinant, which is 1 plus n times n plus 1. That's coming from the determinant of the 1 and the 1 with the n and the minus and minus n plus 1. And of course you can see that this term here is the same as the first factor that we found. So in fact this determinant is equal to n squared plus n plus 1 all squared. So an appropriate method, part 1 will gain you 1 mark, and then for pulling out the correct factor, give you an accuracy mark there. In part 2, again a method mark for trying to find the remainder of this determinant, and then an accuracy mark for ending up with the correct expression at the end of it. Now, what happens in part B? Well, part B now asks you to expand this determinant directly. In other words, you're not going to do any row or column operations, you're just going to expand it using a suitable row or column. Okay, and we're looking for n plus 1 all squared, and we can see we've got an n plus 1 here. So, sensible thing would seem to be to use the first column because of the fact we have a 0 in there. So if we do that, this determinant is going to equal n times n plus 1 multiplied by, and it's going to be 1 times 1 minus n times the minus n plus 1, so that becomes plus n plus 1. And then we've got plus 1 times the determinant of n times n plus 1 plus 1. Okay, now we need to write this in the right form, and you can see we wanted an n plus 1 all squared. Well, we can see here we've got an n plus 1 times an n plus 1, so that is going to give us an n plus 1 all squared. And we've still got plus the 1 times the n times n plus 1. And then from the second bracket, we got 1 again times the n plus 1. And then we've got a minus 1 on the end there. You know, I was just looking at that minus 1 and thinking, no, that's not right, and you're quite right, it isn't. Because when we did this determinant over here, it was n times n plus 1 minus a minus 1 times 1. So that's a plus 1 there. Okay, if we now multiply out, we've got the n plus 1 all squared, and then we've got 2 lots of n squared, got an n squared from both brackets. We've got a 2n from both brackets, and then we've got a plus 1. Now the question is, how are we going to get this sum of 2 squares in here? Well, leaving that first part alone again, we can see or know that n plus 1 all squared gives you n squared plus 2n plus 1, so it gives you this term and this one, and it only gives you one lot of n squared, so I need to add on an n squared to complete that part of the expression. And so now we have what we require. We've got n plus 1 squared, and then we've got this function here which is expressed as the sum of 2 square numbers as required. Finally, in part C, it says hence express the number 1, 2, 3, 2, 1 as the sum of 3 squares. Okay, well, what have we got? Well, we've got in the first part, we said that the determinant is equal to n squared plus n plus 1 all squared. And in the second part, we said that it's equal to n times n plus 1 squared plus n plus 1 squared plus n squared. So what we need is an appropriate value of n that will give us 1, 2, 3, 2, 1. And then hopefully on the other side here we will then have our sum of 3 squares on this side. So if we let n equal 10, then this left hand side will become 110 plus 1, 111, and 111 squared is 1, 2, 3, 2, 1. And so if we put 10 in on this side, we get 10 times 11, so that's 110 squared. 10 plus 1 is 11, so that's 11 squared, and 10 squared is then the third square that we require. So there is the result by combining parts A and parts B together. So where are our marks coming from here? Well, in part B, this initial statement would gain you 1 mark, and then working through to get this appropriate form would give you a mark. And in part 2, we're realizing that you can set n equal to 10 in these two equated parts, and then coming up with this answer from there will give you your second mark. Well, hopefully you found that solution helpful. For more help with your maths revision, please go to the Further Maths Support Programme website.